Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is equal elements. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. An array B of size 2 times m is called good if it holds the following condition. That is, for all the indices I to m, the value of B of 2i minus 1 is equal to B of 2i. So for example, if our I is 1, then it means that 2 minus 1, let's put the indices here. We have a I, we have 2i minus 1, and we have 2 of I. If I take I as 1, we are talking about 2 minus 1, that is 1 and 2. If we take I as 2, then we're talking about 3 and 4. And if we take I as 3, we're talking about 5 and 6. So in a way, we're talking about adjacent elements 1, 2, 3, 4, 5, 6, and so on. Now, these elements have to be equal for them to be called a good or a good array. Now, we are given an array A of length n and we need to find out the longest subsequence of A which is good. A subsequence is formed by deleting several elements from the array without changing the order. This is the important part that we need to take care of. Now, for the input format, we have t test cases, and for each test case, we have two lines. The first line contains the integer n, that is the size of our array, and the second line contains n spaced integers, those are a1, a2 till an. As for the output format, we simply have to output the longest or the length of the longest good subsequence of a. As for the constraints, number of test cases will go from 1 to 10 raised to 4. Length of the array will go from 2 to 2 into 10 raised to 5. Values of the element in the array will go from 1 to n. Let's see some sample inputs. So for the first sample input, the array length is 4 and the elements are 1, 1 and 3, 3. So we can take the complete array as a subsequence. We have the elements at 1 and 2 as equal and 3 and 4 as equal. Therefore, the length of this array or a good subsequence in this array is equal to 4. Let's take the final sample input as example. We have 9 elements and those are 1, 2, 1, 2, 3, 2, 3, 4 and 4. Let's choose the elements. We'll choose 1, then we must choose the other element that is also equal to 1 to satisfy the condition. So we'll take this one. Now we cannot take this 2 because we have already taken this one, so we cannot choose previous elements. So next up, let's say we choose this 2. If we choose this one, the next element must be 2. So we choose this. Then we can choose this 4 and 4. So now in total, we have chosen 1, 2, 3, 4, 5 and 6 elements. So the subsequence that we have chosen will look something like this: 1, 1, 2, 2 and 4, 4. And the maximum elements that we have here is 6. And that's the answer here. Let's see how we can approach the solution. Let's say we have our array with us. And once we start choosing the subsequence, we start with the element at ith index. Now let's assume the element at ith index is x, right? Now if you're choosing the next element, let's say it is at j index, then the other element must be equal to x. If that is not the case, then we will not be having a subsequence that is good as per the condition, because as per the condition, the next element or the second element, in our case the first element is x, then the second element must be x and it should be equal. Now let's say we have chosen I and j. Now when we are choosing the third element, let's name it k, k cannot fall between I and j, because if you remember, the condition for a good or a subsequence is that the element's order should not change. So if you have chosen I, j, then k must be greater than both I and j. Therefore, k cannot be here. K must be outside, right? This can be seen in our example as well. We have chosen 1 here. The next element must be 1 that we chose here. Now we cannot use this 2, although we might be tempted to use it because we can have 1, 1, then we can have 2 and another 2. But this previous 2 cannot be touched. So what do? We start with the element and we have to find the next element that is same as this, the previously chosen one. Once we find this, we restart the process again. you forget about all the elements that came before. So the approach that we can use is of having a set. We'll have a set, right? Let's go with the first example. We had something like 1, 2, 1, and again let's say a 2, 3, and 2, right? So we'll first add the element 1. Then once we go to the next element, we check whether that the element already exists. If it does not, we'll add it. Then again move to the next element. If it already exists, it means that we can form a pair. So we'll have 1 and 1. So now whatever elements that we have seen till now, we'll have to delete them. They cannot stay still here. Then from the next element, we again start the same process. We take 2, we take 3, because this is the first time they are occurring. Then once we again encounter 2, we have found our pair, right? We'll add them and again empty the set. With this, we will form a subsequence that is the longest and also is good. That is, it satisfies the condition that is given in the question. And with this, we'll have our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n, and then we take the input of our array. Now once we have this, we initialize our result to 0, and then we initialize an empty set. Then we go over all the numbers. When we have a number and we are taking it into consideration, we'll check if it already exists in the set. If it does not, we'll add it in the set. But if it already exists, it means that we have found our pair. So it means our answer length will increase by 2. We increase the length or our answer by 2 and then reset or clear the set. Once we do this, we again move ahead with the next number. At the end, we have the length of the longest subsequence that is good in our array A. And as you can see, I have AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n and the array, then we initialize our result that will be initialized as 0 and an empty set. Then we go over each of the number. If the number is already present in our set, then it means that we have a pair with us. So we increase the result by 2 and we again reinitialize our set to empty. But if that is not the case, and this is the first time that we are encountering this element and it is not in the set, we add it to the set. At the end, we have the length of the longest subsequence that is good. And as you can see, I have AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day and I'll see you in the next video.